Hello, so in this video we're starting a new topic all about cubic inequalities. And the very first thing I want to draw your attention to is this first sentence, which is really important. It says, for any non-linear inequality, you must sketch a graph. Now, the graph isn't going to be our answer, but in order to get the answer, you must graph it. And that's going to make more sense as we go on. But let's now zoom into our very first question here and give it a read. It says, solve this for when it is greater than or equal to 0. Okay, so how are we going to approach this question? The very first thing I want to do is kind of decipher what this question is saying. So kind of writing it down in plain English. So what it's saying is, so write this down with me, when is this function right here, when is this function, and then at the end here we have greater than or equal to 0. So when is this function, well, what this part means is when is this function above or touching, when is this graph above or touching the x-axis, So that is really just writing in plain English what this question is saying. And hopefully you can see also as well that this is approaching it from a graphical point of view. You can kind of visualize what we're doing here. And that's the whole point of this. When you have non-linear inequalities, you have to sketch it. You have to graph it to understand what's going on. Okay, so let's now zoom out and follow these 3 steps to answer non-linear inequalities. So the first thing that we're going to do is find our x-intercepts. By looking at this, we can solve them really easily. Remember, it's already factorized for us, which is really, really nice. So all we need to do is set each of the factors equal to 0 and then solve for x. So for instance, the first one would be x equals 1. That's going to be our first x-intercept. And that is just an ugly, ugly x. Let's try that again. So it's going to be x is equal to 1. This one would be negative 2, and this one will be 5. So what this means, if I were to put x equal to 1 into this, well, I would get 1 minus 1 here, which would be 0, and then the whole thing would be 0 because they're all being multiplied together, and therefore it's an x-intercept. I can now graph that on my graph over here. So I'm going to put negative 2 here. I'm going to put 1 over here, and then I'm going to put 5 over here. Now I'm going to graph it, but I have a question to ask. There are 2 ways I could graph it. I know it's a cubic, so I know the general shape of it, but I could graph it like this, go up, then down, then up. Or I could graph it like this. I could go down, then up, then down. Well, which one is it? How can I know? And the way I know is the fact that I need to consider the sign in front of my x cubed. So I know if I have a positive in front of my x cubed, it's going to look like this. It's going to go up, then down, then up. But if I have a negative in front of my x cubed, it's going to look like this. It's going to go down, then up, then down. So what I need to do is consider what this would look like if I expanded it. Now, let me really stress this. Don't expand it. You would be wasting your time if you expanded it. We can figure out what the sign in front of our x cubed is going to be without expanding it. Because we know if I were to multiply x and x and x, well, I'm going to get x cubed. And that's because they're all positives. So obviously when I multiply them all together, they're all going to be positives. So just like that, I can figure out that if I were to expand it, it would be this one. So now I can come over here and I can give this a graph. I can go up, then I can go down, and then I can go up again. And then we put an arrow there. Then we put an arrow there. Perfect. Now, the next question is, do we need to find the y-intercept here? Do I need to find what this y-intercept is going to be? And I do not need to find what the y-intercept is going to be. And that's going to make more sense when we write down our final answer. So I'll save that for the time being. The next thing I'm going to do is highlight the relevant areas. So those are going to be wherever I am above or touching the x-axis. So let's get my highlighter here and just highlight everywhere I'm above or touching the x-axis. So I'm above the x-axis here. I'm above the x-axis here. I'm also above the x-axis over here. And then what I can do next is just to remind myself that I'm also including where it's touching the x-axis. And the reason why I'm including that is because I have this equal to sign here. So just to really stress this, because I have a greater than sign, it's above, And because I have this equal to sign, it's also including where I'm touching it. Perfect. Hopefully you've got that. And that's what the question I've got down here. Do you include the x-intercepts? And that's really dependent on the type of inequality you've got there. So because it's greater than or equal to, I do include the x-intercepts. Okay, well, guess what? We haven't written down the answer yet. The graph is not the answer. So let me really stress that by writing it in. The graph is not the answer. The graph is not the answer. The graph is helping us get the answer. It's crucial to figuring out what the answer is, but it is not the answer. It is the tool by which we get the answer. The graph is not the answer. Okay, so let us now write down what the answer is. And we can do this in two ways. We can write the answer as an inequality, or we can do it using interval notations. Both are acceptable. So if I was to do it using inequalities, well, I just have to represent this region right here with inequalities. So it's going to be -2 is less than or equal to x is less than or equal to 1, or it is where x is greater than or equal to 5. So that right there would be one legitimate way of writing down my answer, just like that. So what it's saying here is that if I were to put in an x value between -2 and 1, or including -2 and 1, I'm going to get a value that is greater than or equal to 0. And so too with x is greater than or equal to 5. Let's now write this with interval notation. So it's going to be x is an element of, and now we simply just have to put square brackets because I'm dealing with equal to as well. So where is it between -2 and 1 with the union of square bracket 5 to infinity, and there's a circle bracket on that one. And just like that, we have written the other legitimate way to write my answer. I preferably like the interval notation way. I just want to conclude this video by talking about why you don't need to find the y-intercept. And the reason why you don't need to find it, let's just, for example, imagine that I drew my graph like this. It was just a sketch. Let's just imagine I drew it like this. So now my y-intercept would be over here. Does that change my answer? It doesn't change my answer. I'm still above the x-intercept. How far above it I am makes no difference. So that's why it doesn't matter. Let's remember what our very first thing we wrote down here when we kind of deciphered the question. The question that we're answering is, when is this function above or touching the x-axis? And our answers here are addressing this question. I'm above or touching the x-axis between these intervals. It doesn't matter how far above it I am. So therefore, finding the y-intercept would be pointless. In much the same way, it would be pointless to figure out, like, how far do I have to dip down here? How far do I have to go up here? The magnitude is not important. The sheer fact that I'm above the x-axis is what's important. So do not find the y-intercept, because the graph is not the answer. It does not concern us. So there are our answers. Hopefully this all made sense. There will be lots of other examples after this to consolidate the learning, and I'll see you in those next videos.